Whether you're going to take a welding test or not in the near future, there's some good tips in here just for vertical uphill welding with stick. Last week we did the root pass. That part one is the root pass, and just to reiterate, stay on the front of that puddle and hold those corners a little bit to avoid undercut. Keep a tight arc. You want to burn into all three members. Read the WPS, the written procedure. Second pass should go in there something like this. Just a very slight weave. You can even in your mind do a little bit of a rainbow type of a motion, a little arc. But hold those corners and don't spend much time in the middle. Just kind of shoot from corner to corner, staying on the leading edge of the puddle. Tie in for the second pass, drag it down, keep all the arc strikes inside the groove. Same thing, good tight arc. You got to have the machine set hot enough so that you can hold a good tight arc without sticking. Now, I've got the arc control on this welding machine set to like max dig. What's arc control? Arc control is a function that adjusts the characteristics of the arc. When you've got it on high, what it does is the tighter the arc at amperage. All right, weld all the way out to the end. You're not going to impress anybody by stopping short half inch saying that's not going to be tested anyway. Weld all the way out to the end and then some. You want this whole thing welded. No, that's not going to be tested out there on the end, but passes as flat as possible. A little bit of convexity is okay, but if you have too much, you're going to have a hard time burning into the corners. And hold the corners tight. Don't spend much time across the middle. Got to keep a good tight arc like this. Hold those corners. And you don't just bounce from side to side, but you certainly don't spend a lot of time across the middle. Hold the corners tight. You can hold those corners a lot longer than you think. Really about a full second is about right. Now, this would be a slight weave here. It's not always allowed. I'm just showing this. If it is allowed, this is what I do all the way out to the cover pass if it's allowed, because you're a lot less likely to trap slag or have any lack of fusion or anything if you can weave. All right, and that looks something like this, and this is just about ready to put a cover pass on. Just slag stringers sometimes are required, so you need to do both. Here's the problem with stringer beads. All right, sometimes you have a little bit of a tight area on that last pass, and you got to make sure and leave enough room to get that last pass in when you're stacking them across the thing. And it's always going to be crowned up a little bit on vertical up too. So, if you can weave, you can carry a hotter puddle. But weaving's not always allowed. So if not, coming across with that first layer of stringer beads after the second pass is going to look something like this. Again, we're holding a good tight arc and just gradually moving that thing up, trying to keep our rod angle at about 90 degrees. A slight push uphill. It looked like I had a lot more than I did there because of the camera angle. A slight push uphill won't hurt anything. Leave yourself plenty of room. See, this is going to be easy to get in there. I left it a little extra room. Okay, so I got to go a little wider on the last pass. So you can see, all I got to do is just barely move the electrode a little bit from side to side. And if I've got it hot enough, it's going to burn in there. It's even going to burn in a little bit of just a little undercut or a little slag if I have it in there, which, you don't want that, but you got to be real. Again, if it's allowed, you can clean this thing up a little bit with a grinder before each pass. But this is I'm in pretty good shape here for a cover pass. Okay, I got those first layer of stringers put in there after the second pass. It's fairly flat across there. I haven't chewed up the edge too much to make it wider than it needs to be. And now it's going to be the first stringer starting from left to right. Wow, not done yet here. Okay, we're going to put in the rest of this. I'll show you the tie-in here on the rest of this pass. This is in pretty good shape here. I've got plenty of room to get in there. I'll show you again what it looks like if you're not leaving yourself enough room. See, I've got a little bit more of a groove to fill in here. I'm in better shape than I was here. All right, careful on the arc strikes. You don't want any arc. You can strike the arc right ahead of where you're going to weld over again. That way you weld over top of any arc strikes. And if you've got it set enough amperage, burning through any arc strikes or anything you deposit ahead won't be a problem, especially uphill like that. All right, it's about really not any hard and fast rule. Read the WPS. If there is one, that's a welding procedure specification. Oftentimes they'll hand you one and read it over, It's got amperage and pass weld sequencing and how you stack the beads in there, and you want to follow that. So there's the first bead on the cover pass going. You can line up the electrode with the edge of the bead, and it'll work out about right. Again, just keep a tight arc. If you go too slow, it's going to hump up. You know what happens when you go too slow vertical uphill. Heat builds up and it just sags on you. So you're going to keep your, you got to go fast enough, watching the toes of the weld, try not to leave any undercut. You can do a slight little circular motion if you want to, or just a slight side to side. You don't really have to do much of anything. Now on the last bead, you want to watch the right-hand side, watch the side with the base metal so you don't leave any undercut. There are limitations on undercut on a structural welding test, plate test like this, on the outside on the base metal. You don't want to leave any on the base metal if you can help it. So that's a three bead cover pass. And clean it up real good. Take a file and scrape those edges and make sure you don't leave any slag. That way you can tell if there's any undercut yourself as you inspect the final weld. Here's another view of it. 3 beads. You want to have it fairly uniform. Again, if it's allowed and you can do a cover pass with a weave and you're more comfortable with that, you're probably more likely to pass the test, because you don't have to worry about all that stacking beads and leaving room and all that. But it's not always allowed. So you need to be prepared to do stringers. If there are impact tests required, if it's the type job you're going on, the engineers have deemed it necessary to. Okay, visual inspection highlights here. The height of the weld needs to be equal to or less than 1/8, and undercut equal to or less than 1/32. There's lots of other requirements, but those are 2 of the main ones. So if you've got a good looking weld, it's been my experience that you can get away with a little bit of extra height, but not always. You can't depend on that. So you need to be prepared to have your height of your weld 1/8 of an inch or less. And I've just pushed the limits here. You can see you can lay a 1/8 rod on there, and it's just about exactly 1/8. I tried to pick the highest spot of the bead to do that little test. There are instruments that do this a little bit better, but that's pretty much 1/8, maybe a tad more. And undercut is the other thing. You want to look at the toes of each edge of the weld, and take the corner of a real sharp chipping hammer or the corner of a file, rub it all in there, get any little slag that you can out of there. It's always best practice. Clean that weld as good as you can. All right. Also, there's a lot of other defects, but here are some main ones.